So till now we have understood two aspects which are important from the point of view of the sigma level or the concept when somebody says that okay, my process is at 6 sigma or at 4 sigma. First was the specifications, second we spoke about the standard deviation. Now coming to the third aspect, we know that the quality of any process is an aggregate of the individual quality levels for each product. In our case, this quality is how much each bottle is close or far from 1000 ml. Let's say we take a new sample of 100 bottles and we count the number of bottles at each volume level. Like let's say there are 20 bottles at 1000 ml. Let's say there are 16 bottles at 995 ml. Or 16 bottles at 1005 ml. And with this data, let us plot a graph which shows us the number of bottles at each value. So this is the plot we are talking about. Such a graph is called a frequency plot or a histogram in this case. Each bar in this histogram, it represents the number of data points at a specific value or the frequency at a specific value. Like at mean 1000, we said there are 20 bottles. Looking at this histogram, obviously the peak is at the center. So the majority of the samples are around mean. That's what it means. That's good news as the process is producing many of the products precisely meeting the customer expectations. But then we also see that on either side there is a tail in this histogram. On the left side, it means that the filling process is underfilling few bottles. On the right side, it means the filling process is overfilling few bottles, which definitely is not so good news. From an academic point of view, such a frequency plot is called a distribution. The most common of these distributions is the normal distribution. You must have heard about this normal distribution during the performance reviews. By look, we can tell it's a bell-shaped curve. It is also symmetric about the mean. Symmetric meaning area on left is equal to area on right. In case of this normal distribution, mean, mode and median are always going to be same. Mean obviously because it's the average and it is going to occupy the center of the curve. What is mode? It is the number occurring maximum times or with highest frequency in a set. So obviously point at the center will be occurring maximum times. What is median? When we arrange a set of data in either ascending or descending order, then the data point that divides this set in two equal parts is the median. Again, the point at the center, this point at the center, divides the curve into two equal parts. That's why mean, median and mode are equal in case of a normal distribution. Area under this curve, area under this normal distribution curve is 100% or 1, which is obvious because it contains all the data points. Theoretically, it is said that the tails of a normal distribution, these tails of this distribution, they stretch to infinity and they maintain themselves parallel to the x-axis. That is referred to as the asymptotic behavior of the normal distribution. And in such a distribution, we will see that at the center it is quite denser as compared to the tails. So these are the typical properties of a normal distribution. So by now you would have guessed that after specifications and standard deviation, normal distribution is the third important aspect while trying to understand sigma level. And why is it important? Because it helps us visualize how the data is spread, and more importantly, it helps to quantify this visualization. One of the most important properties of normal distribution is that it tells us progressively from mean what percentage of data set we can expect. That is, let's say in the range of plus minus 1, the range of plus minus 1 times the standard deviation from the mean, we can expect 31% of the data to lie. Like in our earlier example, we calculated standard deviation as 5 when we had taken 5 samples and mean was 1000. So it means that 31% of the bottles will have their volumes between mean, which was 1000, minus 1 times the standard deviation, which was 5. So 1000 minus 5. So this value becomes 995. And on the higher side, it becomes 1000 plus 1 times the standard deviation, which was 5. So 1000 plus 5, this becomes 1005. So in this range, which is 995 to 1005, we can expect 31% of the data to be present in the distribution. Similarly, in the range of mean plus minus 2 times the standard deviation, we can expect 69% of the data. In the range of mean plus minus of 3 times the standard deviation, we can expect 93% of the data. And by the time we reach mean plus minus of 6 times the standard deviation, we can expect 99.99966% of data, which is like almost 100% of the data.